Okay, so we're going to talk about ducting sizing. We're going to talk about how to work out the area of the duct and also the velocity going through the duct and what volume that equates to. So there's other things to consider when sizing ducting. So it's the conveying velocity required, the material size you're handling, and machine connections, hood requirements. So welding machine, for example, the HSE guidance on this is up to 10 meters a second velocity, and wood shavings is in the region of 20 meters a second activity. So we need to calculate the volume of air needed in the duct. So we start with working out the area of the duct. We're using the formula pi r squared. I'm sure you'll be familiar with this symbol. It is basically the easiest way to reckon it is it's 3.142. So we're looking at the pi times r squared, and r is the radius of the duct, so that's half the diameter in meters. So if the diameter is 150, we're going to divide that by 1000 to give us meters. So it's 0.15 of a meter, and the radius is half the diameter, so diameter divided by 2, so 0.15 divided by 2 gives us 0.075 meters. Then we can square the radius and times it by pi. So if we're squaring the radius, that gives us this number, and then we times it by pi, 3.142 gives us 0.0176 meters squared. So if you want to use the formula to work out the volume, so volume equals velocity times area. So in the first example of 10 meters a second times by the area, 0.0176, gives us a volume of 0.176 meters squared, which is meters squared per second. So if we want to convert that to a more tangible number, which a lot of people use, is meters cubed per hour. So all we do is times by 3,600, which is 60 seconds, 60 minutes. So 60 times 60 is 3,600. So if we take that meters cubed per second value, times it by 3,600, gives us 636 meters cubed an hour. So if we want to extract in a 150 duct at 10 meters a second, for extracting welding fume, for example, we need a volume of 636 meters cubed an hour. And in the second example we talked about, which was wood shavings, so we're changing the velocity to 20 meters a second. We've got the same area because we're talking about the same diameter, gives us 0.353 meters cubed a second. Or if you want to convert that into meters cubed an hour, we times it by 3,600, giving us 1,272 meters cubed an hour, which is exactly double, which makes sense because we're doubling the velocity.